All right. So today we have Paul from Pixar. So definitely, there's a lot of excitement around Pixar's contribution towards USD and all the animation work that they have done in the past. So this is a session probably like a lot of members were looking forward to. So Paul, feel free to take over and make your introduction and then your session content.
Hi everyone, my name is Paul Kanyuk, and I'm going to be talking about UsdSkel and character interoperability and how that applies at Pixar. A little bit of an overview. First, I'll go over the backstory of why am I talking to you guys about this. A little bit of an overview of what UsdSkel is, a tour of our open source example that Pixar provides, as well as how UsdSkel both plays a part in our production pipeline and sort of how it works with character interoperability outside of our typical pipeline and work for the future. So a little bit on my background. I got started at Pixar in 2004-ish as an intern. Got started in shading and render optimization, but around 2006 on Ratatouille, I started getting involved in crowd simulation. That kind of became my specialty. And starting on Brave in 2012, I began leading crowd teams. And I think finished my 6th or 7th show leading a crowd team on Elemental. But between doing crowds, I also do research and development, including work with UsdSkel, helping studios like Disney Animation get started with it and such, as well as a lot of engagement with Disney research. So that's a bit on my background. So where does UsdSkel come in that whole list of things I've worked on? Well, the story kind of goes back to Pixar's crowd pipeline, circa 2006 to 2010. Like many studios, we were doing agent-based crowd simulation in Massive, and we had a pipeline that would connect Massive to our proprietary animation software, Marionette. Now, Marionette did everything from rigging all the way through lighting, and then we rendered in RenderMan. And we had a crowd pipeline that basically would ingest rigs from Marionette and output animation back into Marionette. And that was working great on a number of films, from Ratatouille, WALL-E, Up, and Cars 2. But then we had a pretty big pipeline upheaval where we switched over from Marionette to a new system that we call Presto. And that's actually what we're using today. This is kind of Pixar's modern, multi-threaded, high-performance animation environment. And that kind of broke things up a bit. You'll notice that Marionette is still around, connected with this geocache line, but the crowd pipeline was orphaned. Massive no longer connected to Presto, and as a result, we didn't really have anything to work with for crowds in the film Brave. That said, note how we still had this way to get from Presto to Marionette via geometry caching, and that proved critical both for crowds as well as the wider CG ecosystem, because that geometry cache format that we called TIDScene at the time for time index dictionary scene was actually the predecessor to universal scene description, essentially a combination of that fast geocache format with the composition features that we had in Presto. Ultimately became USD. And that's actually what Pixar's crowd pipeline was really built on for a number of years, was just a fancy way to sequence geometry caches together without even caring about the character's rig, because we lost our crowd pipeline, so we were just working with what we had. Now, to some of you that might sound surprising, why were we working with geometry caches? Why not skin skeletons like everybody else in the industry? Well, one of the reasons that in Presto, our rigs are very complicated, and to an extent, they're actually black boxes and not terribly skeletal at all. You can think of it as animation controls going in. There are well over 1,000, even if maybe only 500 are used often. And the rig you can consider kind of a black box. If you peek inside, Presto expresses rigs as a node graph of deformers and weight objects with things called execution markers that allow there to be cycles in the node graph, which is really mind-bending. But suffice to say, there's something skeletal in there, but it's not really the way we rig. And at the end of the day, it's posing geometry. So we kind of have to learn a skeleton from what that black box is to even work this way. Now, there's a lot of reasons we, to actually turn our rigs into a skeleton that's understood by other pieces of software. Because to be honest, we'd like to get our characters out of Presto. I'm in crowd simulation. We want to use crowd simulators like Houdini, Massive, or Golem. There's also a lot of interest in virtual production to get our characters, say, on a mocap stage or something with immersive environment, to do previs, or even to work with outside vendors to get Pixar characters into games or VR or promotional content. So there's a whole lot of reasons for character interoperability. We'd also love to get outside animation into Presto. Again, crowd simulators, we want to get data out to it and back into Presto. There's also interest in using mocap for crowd motion, as well as more advanced techniques like motion controllers and machine learning to potentially direct their characters. And for all of that, we need some concept of interoperability with our highly complex rigs. So that's why I'm talking about character interoperability. That's how we got to this topic. Now let's talk about UsdSkel. So we ultimately did make the transition to skeletons, and we added skeletal features to USD. Initially, we did our own implementation, and then with a collaboration with Apple and other folk, we ended up creating the public-facing UsdSkel API, which is now what we're using. And this is the link. Here's a blurb to what it is, but suffice to say, the UsdSkel is kind of a lowest common denominator way to represent rigs. I mean, not maybe the lowest, but pretty low in that essentially it's a rig that consists of linear blend skinning and blend shapes and standard things like bind transforms and an API to access them. So it doesn't sound all that exciting if I put it that way. That said, even getting a lowest common denominator to truly be interoperable has been way more challenging and interesting than I thought. So when I introduced to you the open source example, I'll show you some of the ways where things that seem easy can break down or fail in various pieces of software. But that's the idea, that it's sort of a lingua franca. It's not trying to be the most advanced rigging system. It's something that hopefully every piece of software can understand as a starting point. So here's just a little example. I don't want to, you could look at this in more detail on the webpage, but the idea is it's either both binary and ASCII. And if you look at the ASCII, it makes sense. You can define a skeleton. Joints are just a list of tokens. Bind transforms and rest transforms are lists of matrices. An animation is described as a list of joints the animation applies to, as well as translations, rotations, which are floating point quaternions, and scales. And doesn't look like much. That's pretty much the standard stuff you'd expect from skin characters. The mesh itself, what it needs to know about is which skeleton it belongs to. So there's a relationship attribute called skeleton that points to what skeleton it belongs to. And then you have these primvars for the joint indices and joint weights, as well as a bind transform that represents where that mesh was when it was bound to the skeleton. So pretty standard stuff. Blend shapes get a little more complicated, but not much. Just at the end of the day, it's pretty much what Maya has. It's both regular blend shapes and in between blend shapes with weights between them. We pretty much adopted Maya's blend shape format, and then it's expressed in USD. Now, if you want to give it a try, the first thing I recommend doing is going to Pixar's webpage. Basically click on the OpenUSD link. Then there's this downloads and videos link, and there under assets, you'll see this UsdSkel examples. If anyone wants to test out UsdSkel, this is what I recommend starting with. This, believe it or not, is actually my contribution to UsdSkel. I didn't work much on the API other than more specifying it rather than writing it, but I was asked to put together an example. So I took a Toy Story 4 asset. This is actually a character named Camilla, a background character from Toy Story 4, who was deemed suitably generic as to be open sourced and made available to everyone. So let's take a peek at what's inside this UsdSkel asset. So USD comes with a viewer called USD View, and this is what I've used to open this asset. And I'm basically making the guides visible and envisaging her geometry and showing the skeleton that's underneath the hood. So pretty standard. Notice it's got fingers and eyes. And if you zoom into the face, you'll see that there's some okay facial articulation, eyes closing and opening, mouth opening and closing. That's done with blend shapes. But there's also variant sets, and I'm switching this rig variant from full to face bones. Now, this is a version where the face is actually done with joints, so that this open source example both exercises joint-based facial animation and blend shape-based facial animation, the same rig. There's also an orthogonal variant set for, that's showing essentially no facial animation. So there's 3 rig variants, and there's an orthogonal geometric LOD that has essentially decimated versions of the character, which should work with every rig variant. So in addition to just being a single character, this asset uses USD's variant features to have essentially multiple versions of the character in one. Bonus points for any software that can import and maintain those variant sets, but clearly it's up to whichever software vendor what they want to support in USD. We just wanted to make sure that this feature was exercised in the open source example. So with that, let's take a tour to see how this open source example shows up in various software environments. But before we do that, sorry, I just wanted to explain a little bit why this example is useful. So even though it seems simple, there's actually a bunch of edge cases hiding within this example that can tease apart the different ways software systems import characters. One is blend shapes. I'm actually been very surprised how inconsistent support for blend shapes are in various DCCs, and I think making sure that all software packages can use these blend shapes would help all get us standardized. For what it's worth, there's about 700 or 800 blend shapes on this character. These are blend shapes that were created programmatically, which I'll talk about later why we did that. So it definitely also exercises scale of blend shapes. Another is there are joints with unusual transforms. Some systems don't support negative scaling in joints, and this very much has negative scaling because Pixar's rig use negative X scale for symmetry to basically reflect one side of the body to the other. And that's very much in all the transforms. So we've noticed some packages just don't like that. And, that's one of the things we hope is a standard thing because a lot of people rig with negative scales. Another thing is non-identity bind transforms. I've noticed not all software supports that. One of the first things I look at is when you import this character, check her shoes. If the shoes are not on her feet, you're not supporting bind transforms correctly. So that's another fun use case. And then, as I mentioned before, variants, because there's both rigging and geometry variants. This is a kind of a test case of other packages that want to support that kind of variation. So even though it's a simple example and arguably a very simple standard, it still packs quite a bit of complexity and takes a lot of work for potentially to import it. So it's definitely a good starting point, and I recommend folks start with this asset. So let's see how various people have done. So on Mac OS, if you right click and open this in preview, you will actually see, hooray, the example is playing back, including with blend shapes. So that's pretty impressive. The reason this actually works as well as it is in newer versions of Mac OS, I believe this is actually being rendered with Hydra and the Metal Storm renderer. So this is actually being displayed by the USD API without going through any other package. That's not true in every Mac OS application, but in the preview app, that's the way it works. Let's take a look at Maya, Autodesk Maya. You can, I believe, every version since Maya 2021 or 2022 supports USD import. So here I am browsing for that and hitting import. And one of the other things you'll notice is, Pixar is a Z-up studio. So you're going to have to do a lot of -90 rotations around the x-axis for this example. But once you do that, you can see the animation plays back. But her eyes are closed. What that means is Autodesk has not yet implemented USD blend shape import. I've been told it's on the list of things to do, but it's still to be done. So I still think this open source example is a good thing for folks to test because it'll help get more support for these features. But still, that's been pretty useful so far to pass our assets along in Maya. Here's an example in Houdini. Whoops, sorry, now it's playing back. Okay, so in Houdini, since I think version 18, there's been this LOP context for layer operators. It's essentially a context to operate on USD. And in this LOPS context, if you create a file node and point it to a UsdSkel, you scrub around, you can see we got both linear blend skinning and blend shapes working correctly. But this is also using Hydra to draw directly into the viewport. If you want to bring the character into SOPs, which is the shape operators of Houdini, you have to use this USD character import SOP, point it at the LOP node. There's 3 outputs from that. And if you wire that up to a joint deform node, we're now in Houdini's sort of KinFX character system. You can see you now have linear blend skinning, but no blend shapes yet. So partial support for blend shapes in Houdini, but not quite all the way working with SOPs. Let's take a look at Unreal 5.2. I checked this out recently and was very happy to see when I dragged the character into Unreal after loading the plugin and just did a rotation. I hit play and I got both blend shapes and linear blend skinning playing back just great. So props to Epic Games. Did a great job getting that working pretty well. Now Unity also has USD support. It's a preview package, and I gave this a try. There's a few more steps I find to use Unity. You have to sort of load the payload, which then creates a bunch of assets. You can see the textures showed up, but display color on the hair didn't show up. So, that's another thing that's being exercised, is this asset has a mix of textures and vertex color. So, that's something that not everyone always supports. And then in Unity, you basically use this timeline editor and you drag the USD game objects into the timeline editor and then point that node back at the game object. And then when you scrub in the timeline, you get time-based playback. So animation and UsdSkel support is in Unity, but display color is not working and the eyes aren't open. So still no blend shape support. So that's something we hope is coming for Unity. NVIDIA Omniverse has done a great job. We have both blend shapes and linear blend skinning working just fine in Omniverse. If you zoom in, there's some weird things happening with the eye refraction, but to be honest, I don't know. We didn't really focus on the eyes. It could easily be a mistake in the asset. I've never seen it fully refract in the OpenGL viewport. So, but that said, this is pretty impressive that that's working. So you can see there's already quite a lot of support for UsdSkel in the ecosystem, and we're excited to see it continue to expand and hopefully include blend shapes more often. So a lot of exciting stuff. That's what's out there in public. So now let's focus back on how we use UsdSkel in Pixar's pipeline. So now that I've shown how you could represent a character in UsdSkel, I also mentioned that Pixar's rigs are not exclusively skeletal. They're kind of these weird black boxes. How do we get our production rigs into this UsdSkel format that is useful for crowds in interoperability? So we have a few systems. The first is called FrameBaker. What it does is exercises every degree of freedom in the rig and does non-negative least squares optimization to solve for the skinning weights that would best deform the rest geometry to closely match the example arbitrarily complex rig. So it's kind of like a rig baking technique. And you can see on top is that's the training poses. On the bottom is the resulting mesh. And on the right, you can see the skinning weights that get solved for each bone. And for very athletic characters like this Incredibles character, this is Elastigirl from Incredibles, this actually works surprisingly well. For fleshier characters like Sully from Monsters Incorporated, it's a little trickier. There's definitely your classic linear blend skinning artifacts. So there's been ideas to use pose space deformation to create corrective shapes to minimize the loss, on top of the linear blend skinning. And this works, but it tends to be actually more complicated than we typically need for our operations and crowds. The body deformation differences are not quite as important as the faces, and we'll get to the faces next. But first, here's an example on Helen. aka Elastigirl, where in yellow, that's the difference between the original and the baked version. So it can actually be quite close for very athletic characters. But faces is where this technique gets tricky. Before we had UsdSkel blend shapes, we actually tried adding face joints to the character. So basically bones that track positions in the face. We're almost doing like mocap, facial mocap on our own characters. And then basically adding those face bones to the frame baker calculation. And you can see when you compare the original to the approximation, it's close. The other one is a little lumpier, but it's pretty close. What's trickiest is the eyelids don't work super well. This is a quality test where we worked on Hector from Coco, who has these very thin eyelids that no matter how many bones we used, we really couldn't get it to correctly approximate the eyelids. So there's a certain point where there's like a quality maximum to face joints where blend shapes helped us exceed that. So this basically brought up the question, how do we learn and derive blend shapes for a facial animation, which isn't necessarily blend shape based. A lot of it uses like wire and curve deformers and all sorts of techniques that and subdiv projections, and don't necessarily combine linearly like blend shapes. How can you approximate that? We actually, went all out, and in 2020 we published a SIGGRAPH paper on FrameBaker, which of course uses machine learning to do a neural network to map animation controls to corrective shapes. That actually worked really well, but it turns out was a little bit overkill for what we typically need with character interoperability. We actually compared FaceBaker against the simplest heuristic that we could think of as a challenger, which was just to take the minimum maximum value of every facial animation control and write a blend shape for it, and just do regular old blend shapes, brute force that way. And it actually looked pretty close to the machine learning version. So it actually ended up using that simple heuristic. The one thing that helped the heuristic was rather than using the true min and max of the control, we looked at the min and max that was actually used in practice by animators to narrow the ranges a little, to be a little more accurate. We also tried in between shapes, but in betweens didn't seem to add much value. Just a simple min and max worked pretty well. And here's how that worked on characters from Elemental. So on this film, there's a lot of deformation that was non-skeletal, like these watery features. So this is a character where we stripped out all the skeletal animation and just left the non-skeletal components. And the original rig is on the left, and the UsdSkel blend shape approximation using that heuristic I mentioned is on the right, and it looks pretty close. Even zooming closer in, we can see that it's not exact, but also not a bad match. So for crowds and interoperability, this is great. We don't need to go fully to machine learning to get this more accurate. So that's how we represent rigs. Now that we have our rigs represented in UsdSkel, let's talk about how we use it in Presto. So we actually have a custom procedural model that we call Presto Crowds Foundation. It's an aggregate model for rigged crowds. So it contains a rig that, rather than moving points on a character around, are basically moving joint angles and setting blend shape weights and mass on a giant crowd. It both generates and animates a crowd with a rig. It's highly vectorized and can basically scale up to tens of thousands of agents, and is designed for kinematic, which is to say non-simulated crowds. Fun graph just showing how we vectorize the data. Here's a view of Presto that shows how the rig is live, and we're just changing distribution on the population. You can see live how the casting updates in the Presto viewport. You can see how the orientations can be animated with a look at. And you can see them playing back animation just fine in the system. This is the single looping state on a bunch of characters. And one of the cool things is the system, even though it's procedural and it's a rig, it supports direct manipulation by having callbacks on the dmanip that drop in extra rigging for deforming it. And that works even on top of motion. It's just all part of the rig stack. And here's how it works in practice. Here's a viewport of Presto, where in the viewport we have this crowd mode that lets, sorry, I think I need to hit play. There we go. All right, so this is crowd mode. where as you click in the viewport, it's basically setting attributes on a add action in that rig that is adding agents dynamically to the scene. It's using depth information from Hydra's frame buffer to basically place it on the geometry. So there's no need to pre-process the geo to some kind of nav mesh or anything. It's all just, as you click, you place the agent, and you notice that as you're clicking, you're already getting poses and casting on these characters. And that's because the rig has already been set up for this crowd population. And we're really just, adding instances to it, and it's ready to go. So as soon as you hit playback on this, the characters are already moving and ready to go. So this is sort of a parade scene. So in this next demo, I'm going to show how you can use a curve generator to basically have characters, along a curve so that you can have a parade going down the street like runners and people cheering. And this is all stuff I did in a live demo at SIGGRAPH Asia 2021 in Tokyo. And yeah, so in about 9 minutes, you can create a crowd like that because they did it live. That said, it's kind of a canned demo. I knew exactly what I was going to do ahead of time, but this is all how UsdSkel is ingested into Presto for both scalability and control. Note that those variant sets that I showed before on the open source example have level of detail. So you can have the full mesh or highly decimated versions. Blend shapes, you can actually mix and match them. So they can have blend shapes from one clips on top of the poses for other, which is useful for changing the character's expressions or adding blend shapes to a system, say like Houdini, that at the time we did this didn't support blend shape export. Speaking of Houdini, we have a USD import node that is basically is part of the PCF where we can import crowds exported from Houdini. Here's an example of an agent-based crowd sim we did in Houdini that we imported into PCF. Note that this simulation didn't make it in the film. It was considered a little too scary for turning red. So in the end, we had a much more tame, shocked crowd rather than fleeing crowd. But I still love that example because it really showed off how we could have interoperability with Houdini at a large scale. A lot of why we're doing the UsdSkel stuff is also to get things out of Presto, not just into Presto. So here's an example that shows the playback of a USD file that's exported from our PCF crowd. Note that even though it's vectorized in Presto, for the sake of interoperability, we export it as a single UsdSkel character per agent to make it easier to consume in other pieces of software. To make that scale, we use scene graph instancing. So all the unvarying data of the character is tagged as instanceable. And that means USD is only composing that data once and reusing it in multiple places. So even though we're no longer vectorized, we still cling on to some scalability by using scene graph instancing, as well as, of course, those variant sets. And then once you have it in USD view, this is just showing off how you can change a different Hydra renderer. So this is going from OpenGL HD Storm preview to path tracing with RenderMan XPU. So that same crowd is now being path traced interactively in the USD view. I know this is not, I guess, a terribly amazing demo compared to what other folks have shown recently with path tracing, but I wanted to show that once you have your characters in UsdSkel in USD view, you now have a choice of many renderers to use, anything that supports Hydra. All right, so we're about to wrap this up. This brings us to the topic of what about more advanced rigging? There's a lot beyond just linear blend skinning and blend shapes. OpenUSD has announced OpenExec, which is a project in its early stages that will eventually have an execution engine within USD that opens the door to expressing rigs in USD, the arbitrary rigs potentially. And it appears that we're using Presto's rigging system as a framework for this, but don't hold your breath. This is going to take a couple of years, I think, to get out there. But that, I feel like, is the direction things are going. Another possibility is, like that FaceBaker stuff I mentioned, is neural networks are ways to express arbitrarily advanced rigs that can be run on many systems using inference. So you can think of a neural net as potentially being more affordable than the original production rig. And we're already seeing examples like the ML deformer in Unreal Engine that are building on this concept. So I wonder if on the way to OpenExec, if people are going to lean more on ML deformers as a way to move more advanced rigs around, potentially. But in the meantime, I'd just be happy if there's more support for just the lowest common denominator stuff in UsdSkel. But just looking in the future, that's the kind of stuff that I feel like the places we're going. It's also worth mentioning groom. So you've noticed none of the characters had hair that I showed in UsdSkel. We transfer that information, but we don't draw it in USDView because Pixar, we have our own proprietary hair system. So we keep the input parameters along with the asset and it renders at the end of the day. But for character interoperability, that doesn't help. Note that basis curves in UsdSkel can be rigged. They can have skinning weights, just like meshes. So that is one way to consider transferring grooms, is as rigged curves. You can also define the points per frame, but that can get really ugly. I've seen a file that's like 20 megabytes become 4 gigs real quickly if you define the points every frame for hair. So while USD supports it, I still think it's an open question on the best, most compact way to represent grooms in USD. So I still think there's room for discussion there. But for now, if anyone really needs to get this done, you either want to skin some curves or do points per frame and eat the cost. So yeah, that is pretty much what I've got. This slide isn't terribly interesting, so I'm going to stop the share. Cool.
Yeah, thank you, Paul. Great presentation. Learned a lot about USD. Yeah, thank you for the whole educational content. We do have some questions in the chat. So if you, Leonard has asked, is there a preferred blend shapes system, algorithm setups, etc.? Are the correct results documented someplace?
This came back on the slide that you presented early on, where you first showed that there were a number of issues that you brought up before going through all the examples in the various commercial tools.
Okay, so you're talking about the issues with the facial bones?
I put it in chat because I knew I wouldn't remember the details. So
Okay.
Let's see, if you go back, and it's probably like slide 6-ish or so.
All right, I'm going to reshare. Okay, this is slide 6.
Nope.
It's probably a lot further down.
2 or 3 after that. No, not way down there, way up.
Okay, so
it's after you talked about the pipeline and the geocaching for your geometry, and then the examples. This up back before you do any of the imports.
Oh, is this just the UsdSkel example?
One more, next one. No, the other way. Slide 20. That one.
Okay, so you want to talk about all the edge cases?
Yeah, I mean, because you said that there's lots of different ways to do blend shapes, and there doesn't seem to be general agreement on getting it done. And I was wondering if is because people approach things differently and there's no standards, or if they didn't agree on the standards, or there's multiple standards that each person's following individually. And then for all of these, is there correct results because you pointed out several of the different problems. And so how is somebody to determine if the way they're doing it is correct or not?
Gotcha. So yeah, I think maybe I misspoke with blend shapes. I think there's largely agreement on the Autodesk standard for blend shapes, which has both supports min and max blend shapes with in-betweens and then weights between them. It's more that I feel like there's always been inconsistency in support for them. And I don't exactly know why that is, to be honest. Maybe it's just there's added complexity to doing that. But yeah, I don't necessarily think there's a rival methodology for how to run blend shapes. It's just, I think, been on the complex side of characters that hasn't necessarily been supported. And then the other ones I mentioned were more things like transform support. That's the one where I've noticed have been very explicit. If all of a sudden you import this character and one side of the body is missing, I know that negative scales aren't being supported. If the shoes aren't on, I know that bind transforms aren't supported. So that said, I have noticed in Mac OS Scene Kit, there was blend shape support where the face exploded. So something went wrong there. So there might be some normalization changes, like whether or not the blend shapes are in the transform space of the character or not. But in terms of blend, like what the fundamental algorithm is, I think it's pretty standard out there. So I may have misspoke when I presented this.
Okay, and then also, and either I zoned out or just missed it, but I didn't see anything on Blender. Did you happen to look at Blender in all your example cases?
So it's funny you mentioned that. We don't use Blender at Pixar, but a lot of folks do, including Disney Research. And I am trying to get a Disney Research project working in our pipeline right now and getting interoperability. So I'm walking the walk with character interoperability right now. And I am looking into that. I tried just doing like from PXR import USD, and that didn't run. So there's probably something I need to do to build Blender with USD, or some plugin I need to use. Does anyone here know offhand?
I don't, but I know somebody who does. Who at least who really understands Blender.
Okay, yeah, I might like that contact info, because yeah, I'm looking into what it would take, because in general, if Blender can import USD, I feel like if they haven't, done all the various import export features, it wouldn't be hard to implement them on top of that, because Blender's got a great API from what I can tell. So, but yeah, I apologize for not having the latest state on that. It's just, I guess, a lot because we don't use it very much, even though I know a lot of folks do.
Actually, so I'll give you the name. His name is Julien Douar. He does a lot of work with Kronos on the GLTF importer. So I don't know what his USD knowledge is, but he does understand the Blender side of things really well. And I'll get your contact information and send you his.
Awesome. Thank you so much. Because yeah, right now I'm trying to get matrices out of Bones and Blender, get them into Presto, and yeah, I am using UsdSkel as an intermediary from this stuff. But I literally just started on this today, so I'm finding out as we speak.
Great question, Leonard. Thank you, Paul, on that. I had one question in terms of the use case with USD. A lot of the things that you showed kind of cater towards like cinematics or movie. Have you seen or do you see any use cases for like real-time rendering, like immersive experiences, games using USD as well?
Yeah, possibly. I mean, definitely virtual production, which kind of splits the difference between, games and film. It's real time, but for, capturing cinematics. Very much it appears to be used, particularly, I think, with Unreal Engine. I know a lot of virtual production things are done in that, but ILM Stagecraft system, which is proprietary, that does use USD. So there's definitely virtual production use, because I think with games themselves, I hear from friends the biggest challenge is it's hard to include USD in the runtime of the game. So it can be used for import into the engine, but it can't necessarily persist all the way to the final product. I don't know if that's something that's being worked on or that's just part of it, but my impression is it's used for import and export, but not necessarily for runtime yet. But I've seen proposals for like more robust LOD standardization and support with games in mind. So I know there are folks looking into it. I just can't speak to the specifics.
Got it. Yeah, thank you for that information. And just like one more follow-up questions on that, you showed like an example of the import across different game engines. So when probably like, I need to play around with that as well. But when you do that import, does like all the assets get grouped into that USD representation, or does the engine break that down into its native representation. For example, if you import a FBX based character in Unreal, so Unreal will do like a good segregation of like the skeleton, the mesh, textures, and all that. So does that same thing happen with USD, or does USD seen as like one single unit?
So there's different flavors depending on the engine. So my understanding is with Unity, you get a USD game object that points to a USD file, and you ask it to load the data, but then that populates the content area with things like a skeletal actor and textures. So it's sort of like an importer, but you can actually continually re-import and change. So it maintains a connection to the original USD file, but there is a translation that is happening there. With Unreal, it looks like there's two flavors. One is called a USD stage actor that mostly is just a view onto the USD file and lets you interact more on the USD level rather than with the underlying Unreal tools. But then there's an import step where you can do after that, where you can turn the stage actor into UA asset stuff, and then you get all the guts. And there's like kind of a matrix on Epic's page of what is supported by the stage actor versus the full import to UA asset, and it looks like they have a roadmap to continually improve how much is being supported by each of those. So those are the only two engines I know about in their support. And I again, I can't speak directly to it because I don't work with those companies, but I have the impression is that both Unity and Epic are actively improving the integration. It's probably a little bumpy right now if you look at either. It's still called a preview package in Unity, as well as like a beta plugin in Unreal.
Got it. Okay, that makes sense. Yeah, I'll check out the link that you mentioned with the matrix. Yeah, if you have, like, feel free to share it in the chat as well, so that other members can also access it. Yeah, meanwhile, we are towards the last 3 minutes, so if anyone have any questions, we will continue the session as water cooler that will be off the recording. So yeah, so folks can stay back and ask those questions, but there's probably like room for one more question in the recorded session. So if anyone has a question, please go for it.
Not a question, but a big thanks, Paul. That was awesome. Really appreciate you taking the time to do that.
Oh, my pleasure. It was really fun. And looking forward to hearing what everyone comes up with. Just so everyone knows, I was extended this invite from Nick Porcino, who I know is tied in with the community. And it's very exciting what's going on here. Yeah,
no, we're looking forward to making sure that all the hopefully all the pieces begin to align so we can all have an easier life.
Absolutely.